Hey guys, welcome to this week's video on our composite functions homework. The first thing that I really want to get down into is to talk about what exactly a composite function even is before we even get into the math. So let's talk about the definition of composite. So I've pulled that up for us. The definition of composite says that it is made up of various parts or elements. Then we add on this functions piece, and we kind of can marry those two definitions together and say, okay, I'm going to take a bunch of different functions and put them together to create something new. And that's exactly what we're going to do. To give you some visuals of real world examples of composites, things that you might be familiar with: cement, a pebble walkway, Teflon pan, composite board or particle board, a tennis racket, or different sports materials. All of these are usually composite materials. Basically, they're going to take different elements of different things, whether it be rubber or synthetic stuff, and put them together to create something new. So this is stuff that you are more familiar with, but now we're going to apply it in terms of math. The first thing that we want to do in terms of composite functions is a substitution step. So we're going to take it step by step, and this is the first thing that we're going to do. I want to draw your attention to this part of the notation, f of g of x. This right here is strictly notation. Okay? What that means is everywhere that I see g of x, and that, let's do purple. Everywhere I see g of x, instead of x, like I have up here, x, I'm going to plug in this whole g of x function. Okay? And that's exactly what this step says here. So instead of 4x, f of x equals 4x, I'm going to plug in g of x so that I'm going to get 4 times the g of x function. So let's write down what that's going to look like. F of, and I'm inputting the g of x notation. This just tells other people what we're doing and how we are composing our functions. 4 of, and I'm going to plug in that g of x notation, or that function, excuse me, minus 2x plus 3. Now, up to this point, all we're going to do is literally just substitute it in. I don't want you to change this notation. You do not need to substitute it in here because you need to get used to seeing this notation. What this means is on the inside, I'm literally taking that g of x function and plugging it into the f of x function. Okay? And that's exactly what I've done here. Everywhere there was an x in f of x, I substituted in all of the g of x function. So again, this piece here, the two purple boxes, these are your notations. These are to communicate with other mathematicians and your peers, and others who are educated on this content, to let them know what you're doing and that this is what the step was. We'll get to simplifying in just a few minutes, but I want to give you one more example. Let's do blue, sure. So again, we have this notation. So everywhere I see this j of x is where I'm going to plug in this j of x function. And I'm going to do that in the h of x function everywhere I see an x. So remember, also in mathematics, we like to perform safe mathematics And notice that there are parentheses around that j of x. There should be one also right here. That is an ugly parenthesis. That's not getting any better. We'll go with that. You get the point. So, starting out, h of my j of x. So I'm going to tell people what I'm plugging into the other function. And the first thing I want to do is I have x squared. So I would have parentheses, and now I'm going to plug in that j of x function, negative x plus 2 squared. So that is our x squared of the h function plus 5 times the other x, and we're going to insert that j function again. And then close it. Every time we are plugging in a function into another function, just like when you substitute a number into a function, put parentheses around it. Excuse me. Instances like this with the negative and a squared, you're going to lose that negative if you don't do it properly. For now, that's going to be it. I want you to look down below at the matching problem set. See if you can figure out which function matches up with each other component function, and to create the composite functions. There is a little answer guide to the activity right below to see if you're doing it correctly. This is an important step. It seems kind of simple, but if you mess up on the substitution part, you're not going to be able to get the simplification part right because it's not going to work out right. You didn't plug in the right function to the right function.